Hello everyone, welcome to today's class and thank you for joining again. Apologies for the delay. Okay, who is excited to be here? Who is excited to be here? Please respond in the comment section that I'm excited to be here because today's class is going to be very intriguing, but you're going to enjoy it if you focus on the class. All right. So today's class is about system architecture and design principles. And today we'll be covering some topics like introduction to system design, software architect mindset, large-scale system design, and we'll also be managing case studies. And this case study will be focusing on the highly scalable image sharing social media platform. Great. So then I'll be giving you two questions which will cover what we discussed in today's class. All right. Now, what is system design itself, right? So the introduction of the system design will be covering what is system design. Then we have functional and non-functional requirements in system designing. And we also have those non-functional requirements, which include scalability, availability, reliability, maintainability. And then we'll cover high-level architecture components. Okay. Now, what is system design? It is simply the process of planning and defining the architecture, the components, the modules, the interface, the data flow of a software system to meet specific requirements. And these requirements are scalability, performance, maintainability, reliability. Okay. Now, we have practically two types of system design, which is the one that is high level design, which is the abstract one. And then we have the low level design, which is the one that touches the individual sections. Now, high level design, it simply focuses on the overall architecture of the system, and it describes how different components interact with each other, and the technology, the services, and the communication paths are outlined. And the things that follow this concept are the API gateway, the load balancers, the microservices, caching, layers, databases. These are the things we use for high-level design. And for low-level designs, this one focuses mainly on individual components of the system. It goes into code-level details, algorithm, classes, interface. Remember that we have done all those things before. We have done algorithm before. We've done taught classes before. We have taught interfaces before. Now, we're now going to use it, which are the concepts like database schema, the class diagram, the REST API endpoints, and the detailed logic structure. Okay. Now, we want to cover this task of what are the goals of system design? Why are we doing it? We want to achieve something. One of it is scalability, so that our app will be able to handle more users. As the app grows, there are instances where you start with 10,000 users and then people like it and then it sporadically grow to like 1 million users. We want to be able to have a system that can carry that without crashing. Okay, now we also want to consider the performance. We want to ensure that it has a very fast response. When you go on Instagram and it's loading and loading and loading, you are not enjoying the experience. Okay, and for a new application, Instagram is already known and we know it is fast. Now imagine for a new application that the app is slow. You know, a lot of people will just keep dropping and nobody wants to use the system again. All right. Then we have reliability. Okay. This is to minimize the downtime and the failure. Imagine if you open an app and it says currently under maintenance. Or remember when something will just happen and you'll not be able to access WhatsApp and you'll be wondering, is it my internet? Is it this? Now, that is something to consider to make sure that the app is reliable and it never hangs, it never stops. It's always working 247. Okay, are we following so far? Okay, now we also want to consider maintainability. Under maintainability, it is easy to update and fix and extend. So that is what we are particularly about. You want to be able to fix it. Maybe something broke and you're like in the twinkle of an eye, you're able to what? Fix it. It's not something that is taking forever to update and upgrade and stuff like that. Now let us also consider the security. We don't want them to hack our system. We don't want our users details to be out there. We don't want somebody to just hack the system, take all the users details and use it for their own use. So we want to ensure that our app is secure and we protect the data and the users. All right. We also want to consider the cost efficiency. We don't want to do an app that it will consume all our money. We want to make sure that we don't overuse expensive resources. All right. Now, the real world examples, I've mentioned some as I was talking. They are Instagram, right? Which makes use of image storage, CDN delivery, news, feed caching. And then we also have Netflix. I'm sure most of us know Netflix as well. That does video encoding, adaptive streaming, global content delivery network. Okay. Now we have WhatsApp as well, which is into real-time messaging. So as I'm sending it, I'm getting it. So even if MTN is not working, what happens? You can still use your WhatsApp, right? And the delivery is guaranteed. Okay. What of Amazon? Where you can order things and immediately you are ordering, the person is getting it, the seller is getting it. Whatever the seller is doing, you are having a real-time this thing on the system and you can pay online and get everything done. Okay. So now we will start with some motivations for the exciting design problems we are going to solve today. And we're going to be talking about three very important concepts that every software architect needs to understand to be successful in large-scale system design. All right. And so, and finally, we'll also go ahead and talk about the process we are going to follow to solve every large-scale design problem. No matter how scary or how big it may seem initially, like, can we solve this? How do I start drawing this thing? What do I even start with? The best thing is to first, let's get some motivation and discuss the plan for the things that we want to achieve in this class. Now, this class is not like other classes where you have to take what you have learned, like algorithm or technology in isolation, where we're doing sorting algorithm and we have to take each one of them. No. Instead, in this class, we are going to apply the whole entire knowledge and create a real life system that is similar to those that we're using currently in real life, like Instagram and etc. And we'll do it in such a way that we'll design it that millions of users can use it. Now, it is really unfortunate that most engineers need to get a design. They never get to have a design for large scale system. Not all engineers, even no matter how experienced, because it is not all places that design large scale system. And that's why even when you look at it, some of the best engineers, they struggle during system design interviews and large projects that require very, very significant upfront design. You know, when things are very complicated like that, you need to sit down and design it. You can't just jump on it. Right. So this class will be an invaluable experience, which will actually help you to boost your confidence and develop your muscle memory and the tuition behind this process. So for this class, we will not be having questions until after the end of the class. This is to help us to be able to focus on, on what we are doing and be able to get it, because we are doing building blocks. So if you don't get the first level and we move to the next level, it will be hard for you to come back to the first level. You might not understand it, or it will take some time for you to comprehend. So it's best you focus on the class, and after the end of the class, we can now gather your questions and then ask. All right. So in this section, right, we'll be tackling a new and exciting design problem. And we're going to work together to narrow the scope to produce a robust and clean software architecture design and a well-defined API, that is application programming interface. All right. Now, before we go into that, let's talk about the mindset, right? That you need to be successful with this system design. Okay. The first important thing to understand is the concept of abstraction. Now, what is abstraction? Okay, let's use a simple word. When you are cooking, you would definitely think about the ingredients, right? You won't think about, oh, what is the molecular structure of rice? What is the molecular structure of the stew or tomatoes? You won't think about that, because what you're thinking about is, I'm going to need rice, pepper, tomatoes, onions for my jollof rice. Okay, that's like abstraction. That's like taking the high level of what you need, right, into the level of what is expected, right? So focus on we don't need to focus on the in-depth parts. We need to focus on the higher level, right? Okay. Now, so that means that we're thinking about the complexity involved in every move we make. Exactly. So in computer science, abstraction are also extremely important. The way you can't do without the ingredient to cook the rice, that's exactly the same way abstraction is. So if we had to understand every implementation detail of every method or library, or the flow of every bit in the CPU, anytime we implement a method in, let's say, a high level programming language, we won't be able to build anything because it's very complicated. So when working through system design problem, it is exactly the same thing, right? In order for us to design an entire system on a scale of a company that employs, let's say, hundreds or thousands of full-time engineers, and they are reaching like millions of users daily, we also need to go to higher level abstraction. So then when you are solving the higher level and you've solved it, then you bring it down again to the next level and to the next level, and that is how you do it until you reach the final level. Okay. And even as we progress through the design process and we'll go deeper into certain parts of the system, we still need to stay on the abstraction level of a system, and not its low level implementation. So it's still abstract. It's just like when you are looking through when you're using a drone to check the layout of your street. Do you understand? You are not knowing whether each house has 2 bedroom or 3 bedroom. No, you are only looking at the roads. How is this road? Does this place, does this area, does this have a mosque? Does it have a church? Does it have hospital? Does it have roads that are linking to the main road? Exactly. That is exactly what we're talking about here. Okay. And as we progress through the design process and go deeper into certain parts, we will still need to stay on that level. Okay. If not, we will lose sight of the big picture and will not be able to reach that goal that we're trying to accomplish. And that's to get the high level thing of everything. Okay. Now, the second most important concept is that any successful software architect needs to understand that every system is unique and different from the one you designed before. So every instance is unique. You don't have to, once you change one thing in your design, in your requirements, your design will probably change. All right. And that is why you can't memorize or blind copy paste existing solution. Maybe you have designed one um design already, one system design. You're like, oh, okay, this person is asking, okay, let me just copy and paste it and edit. Oh, it doesn't work that way. Right. In most cases, when you change one requirement, it can greatly affect the entire design. Therefore, it will affect the whole software architecture. And because of that, you have to think throughout the entire process and make the right decision at the right moment in the design. So you have to think about it, sit down and think about it. At the same time, there are also quite a few common architectural patterns which are solutions to smaller problems that can help you to save some time. So if you have done some things, you know that, okay, this user always does this, you can always plug and play. How do I mean? Remember when we were doing sorting algorithm and we had to do some breaking, splitting, and merging? Exactly. So you can split your architectural pattern into different segments, and then maybe you have had that kind of structure in the beginning. You can make use of that structure and then think about the rest of the line, but you cannot just dump the whole thing into another process, right? So you can do that to save your time. Okay. So very soon we will see how to apply those patterns in practice throughout the course. Now, what is the third important concept? It is that system design never has one correct or optimal solution. You know, unlike in programming that you say, okay, when I write this function, I'm going to write a unit test, and if the unit test does not pass, that means something is wrong with that function. Or if you say, okay, this is algorithm, right, which we can prove to be correct and optimal. They can say, oh, on or on2, which one is greater, on plus k. You can say, you understand. But in this case, there is no best solution or correct or optimal solution, but there can be bad solutions. That is when your system is maybe consuming expensive resources, or it's not scalable. Exactly. Okay. Now, I really want to iterate that there can be good solutions and there can be even better solutions. So you can make it better, but it's not like that your better solution is the number one best in the whole wide world. Another person will also have a best. Okay. Now, all right, let's go to the next thing, right? So the most important thing here is that having that experience and following the right process will definitely increase the chance of a successful design. Mhm. Now, let's consider the 5 steps design processes. Okay. So, now that we got some high level motivation, we would like to talk about the 5 step design processes we are going to follow. The first step in our design process will always be gathering the functional requirements. Remember what we said about functional requirements. It's the abstract level, is the most important part, like the high level definition of our system design. Since large scale systems are very complex, there is always a lot of things that we don't understand, like ambiguity. When they give us a challenge and say, okay, this is what we are trying to solve, maybe by our client or by our manager or by the interviewer. Now, this process involves you investigating and asking questions to ensure that you understand how the system behaves and how you want it to behave and the best way for it to behave. Now, what do you do during this stage? You narrow down the scope of our problem. Okay? Now, this is the process of getting to know what the system needs and what it doesn't need to do. Now, it also considered what part of the system are already given to us as an external API or an internet service. At this point, we don't need to worry about the design themselves. We don't have to worry about that. What we just have to know is that what the system needs and what the system does not need. That is the first thing to do. It is very important to know that this step is the most critical part of our design. Once you get this part wrong, you will waste a lot of time solving the wrong problem. You will waste a lot of time solving the wrong problem because you will not know what to do and what not to do. And the things you think you are doing is already wrong. So you are definitely leading everybody astray. Okay. Now, we're going to consider the next step in our design process. And what is the next step? It is capturing the non-functional requirements for the system. Remember what we said, that the non-functional requirement for the system does what? It's that critical to ensure our system has the qualities of what our clients expect. In other words, we want to ensure that our system can produce the desired behavior, not just in general, but the given workload and context. Okay. Now, there are many quality attributes that we need to consider for a real system. But for this class, we're going to focus on three things. One, the scalability. Two, high availability. Three, the performance. Remember, these are the three non-functional requirements we want to focus on in this class. And if we try to address every possible quality attributes, like let's say the security observability and the profitability of the app, and so on, you will realize that the design will take so many hours, even more than 10 hours. And in the end, we might not even remember where we started from. So that is why it is best to narrow it down to the most important non-functional. And when you are done with that, you can now go ahead to now expand it again. All right. Now, let's consider the next step in this our process of defining our systems design, right? And the next process is to define our systems API, which is the application programming interface, and capture the sequence of the event. So, because this is programming, you have to tell the system everything you want it to do. You cannot assume that it will know it. So, the system sequence of events is very important to be captured. And in this case, how will we be doing it? We'll be making use of sequence diagram. While we are using this diagram, the first thing we will do is to ensure that all the use cases in our system are covered so that we don't miss any critical step or behavior. And once we finish this design, our API will naturally present itself to us in every interaction between the user and our system, because it will be very clear. You will understand it and you'll be able to say, oh, okay, this is what this one does and this is what this one does. Now, let's talk about the fourth design step. What does it address? It addresses our functional requirements and then creates that software architecture diagram to match our API. So, what does it involve? It involves defining the architectural style. We are going to follow that flow of the network request from the client directly to the relevant services. And then all the details about what data we are going to store and how we want to store it are what we will be considering. And we will mainly focus on, most importantly, the system's functionality. However, we will keeping in mind the non-functional requirements at the back of our mind. So as we are doing that functionality, we are still considering that non-functional requirement. We are keeping it at the back of our mind. Remember what I said, if we do everything at a stretch, what happens? You will forget where you're coming from. But when you do the functional and then the non-functional, you can now improve on it and keep expanding because you have already gotten down the main facts layout. Okay. Now, then finally, we go to the last step where we finalize the software architecture to meet all the non-functional requirements, which we gathered in the second step of our design. What does this involve? It involves adding additional components, like I've mentioned, and removing some potential points of failure or performance bottleneck, and optimizing some critical parts of our system using different data. We can also use sharding or processing techniques. Now, we need to know that software architecture patterns and non-trivial and specialized data structure algorithm ensure that we handle the user request and store our data in the most efficient way for that specific use we are trying to do. So by the time we are done with all the processing, we will have had everything we need to choose that technology that we want to use and implement the system we want to do. Now, this five-step design process, we will realize that the first three steps in this process define our system from different angles externally. If you look at this, you realize that gathering functional requirements, gathering non-functional requirements, and defining systems API and capturing the sequence of events, they are defining our system from different angles externally, right? And then the final two steps, which addresses the functional requirements and create software architecture, and also finalize software architecture to meet all non-functional requirements. What does it do? We go down one level of abstraction. That means we deep dive into the matter and fill in all the details to fulfill those functional and non-functional requirements and the systems API. Can you realize that what we have done now is to first of all do the higher level and then deep dive to do the lower level? Okay. I'm sure that once we apply it in real problem, you will be surprised about how simple and yet very powerful this process can be. Now, I want us to summarize quickly for those who are just joining what we have said so far. All right. So, after we have gotten the introduction and motivation for what we are going to do in the in this remaining side of the class, we covered three important concepts that every software architect needs to understand. And the first one was the concept of abstraction. Remember? Okay. And the reason why I am explicitly explaining this now is because it is a building block for the next thing that we have on our agenda. Now, the first one is to know the concept of abstraction and the importance of staying within that appropriate level to design the large and complex system that we want to design. And then the second was the uniqueness of every design problem, which require us to think and make trades-off or avoid duplicating or copying and pasting solution, since it simply doesn't work in design system at all. It is unique, and for everything you are doing, you have to do it newly. And we also covered the last concept, which was the fact that there is never one correct and optimal solution to a design problem. So it is all about getting the experience and following the right process. Likewise, making the right decision at the right moment in the design. Because if you don't make the right decision at the right moment, you are going to flop. And people tend to use that your system that you have designed, a lot of flop is going to happen that can cost the company a lot of money. So this is why it is important to ensure that you're following these three core mindsets. And after that, we now discuss the 5 steps of the design processes, which includes gathering the functional requirements, capturing all the non-functional requirements, defining our system API while addressing the functional requirements with a high-level architectural diagram, and finally, optimize our system and address all the non-functional requirements. So, these are the introduction to this system design and architecture. So now, when we look at it, I will give, because we've not been asking questions, I will give the space now for questions before the break. And while we are doing that, I would like you to know that we are going to have, after this break, we are going to have real world scenario where we'll talk about it and we'll see the application and how it works. I am saying um in the comment section that somebody is saying we will still do practical today. Of course, we are going to have a real world scenario where you are going to handle, and then you understand better what we have been talking about. Now, because I mentioned in the beginning of the class that we shouldn't ask our question yet, so this is the time. If you have questions to ask before we move to the next phase of our class. So I'm going to be giving 5 minutes for us to ask. If we have any questions, let us ask, or just think about the things that we have spoken about, digest it, because when we are coming back to do practical to build up on what we have done, and it will be very nice for you to catch up on what we have done so far. So, Emmanuel is asking, what is the difference between system design and system architecture? Basically, it is simply the design from the word is like the breakdown, the end-to-end process of everything you are going to need, all the components you are going to need, right? While architecture is the broader one we talk about, we said that abstract level, the high level diagram. So it's about the overall, while your design is about every component that you will need to achieve that. Am I going to need an API? Am I going to need a load balancer? Am I going to need, that's the designing. The architecture is when you place it all together in a view that somebody can say, oh, okay, this and this and this are what we are needing for the. But when you deep dive inside each one of those which one of those components, you will now realize that, oh, we actually have a detailed activity for each one of them. Okay, now what is the sequence? I'm reading question from Ademola, can you summarize the concept of abstraction again? That concept, you can just always revisit that one. We don't have to go over it again. But abstraction is like high level. Just imagine high level. When you think of abstraction, think of using a drone to check a street. Do you understand? So you know that it is, you will not see people, right? When you're using drone, you will not see people that are inside the houses. You will only see tiny, tiny little houses, but you will see all the houses in that environment. That is simply something about abstraction. Right. Good evening, Ma. From a message from Diamond. What is sequence diagram, and is there an app for Designing sequence diagram. Okay, there are so many apps to design sequence diagram, right? There are so many. Now, a sequence diagram is simply moving from one place to another. From the word sequence, is like showing, I wake up in the morning, you draw a picture of somebody waking up, and then you do an arrow to, I go to the bathroom to brush my teeth. Now you draw an arrow again, you draw a bedroom, then person enters. Then you draw another arrow. That is simply what sequence is. Okay. And you can use Lucid Chart. It's quite free. You can use so many things. Okay. What's the next question here? Oludare, is it possible to gain enough knowledge so system architect to qualify for entry level position after we finish this course? Of course. So this course is simply an introduction, right? So now that you have learned about system architecture and design, what do? You go ahead and read more, because you have had an idea of what the high level is all about. Then you deep dive. If you go on to, we have taught every important part that you need to know. Now, if you go ahead to focus more on understanding each part, right? When you learn something, it's in your short-term memory. But when you practice it over and over, it goes to your long-term memory. And that is what you need to do on your own. And the pace you do that is based on you. Right. Emmanuel said, during functional requirement gathering, are we the one establishing the goals or the stakeholder? This one is depending on your stakeholder. There are instances where your business, you have to consider your business goals, and you don't know the business goals. It's the stakeholder that knows the business goals. So this particular question is based on the situation you are in, right? But all you have to do is to ensure that whatever thing you are doing, you do the right functional requirements and the non-functional requirements, you get them right. Emmanuel said, during functional requirement gathering, are we the one established? Okay, I've read that. Okay. Um, Diamond says, please, can you throw more light on functional requirement? I have already explained that in the class, and you can feel free um, to go over the class again and talk about it. But functional requirements are mainly the abstract part of the system, like they're the high level of what your application needs to function, like the main thing it is going to require. Okay, so okay, so I think I have covered all the questions, and if I'm yet to cover your question, please feel free to drop them now, because in 2 minutes I'll be giving you a break for you to submit your attendance. So we still have 2 minutes before the attendance submission. This is the time to drop your questions, because in the next half of the class, I won't be answering any question again until the end of the class. This is to help us not to get distracted so we can all focus. Okay. All right. So somebody is asking me about functional requirements, and since there are no other questions, let me just try to give you examples of what the functional requirements can entail, right? So it's basically it's basically like the user authentication. It is, if you are having an app that people must register, what happens? You must have an authentication, right? You must have somewhere where you process the data. You must have reporting. You must have the user interface. These are all functions that your app. So functional is like the function, the most important thing, the thing that are functioning, that you can say, okay, this app as this, right? So that is the word functional, and that is simply what it means in this context. And it varies based on what you are designing. Diamond, I hope I was able to shed a little more light on that, your question. Okay, now it's time for your attendance, and we'll come back by 8:05. Okay, welcome to the second half of the class. Now, who is ready? Say I am ready in the comment section, please. Say I am ready. I am ready. I am ready. All right. Thank you. Okay. So in this section of the class, we'll be designing a highly scalable image sharing social media platform. Can somebody give me an example of a highly scalable image sharing social media platform? Can somebody give me an example? Very good. Thank you, Jimmy. Jimmy said Instagram. Exactly. Facebook. Great. Right. So, when we're talking about this, I want you to start picturing, thinking outside the box, and trying to understand what we're talking about here. Okay. Now, we'll design a highly scalable image sharing social media platform, and we will start by narrowing down our scope by what? Gathering the system requirements. We will then go ahead to define our system's API. After that, we'll define our software architecture by first designing to fulfill our functional requirements, and then we will now refine it, make it better. That same thing, we'll now build on it to deliver on the non-functional requirements. Now, first of all, let's ask ourselves so that we can understand exactly what we need to design, right? Let's ask these few points. What kind of information do we need to store about each registered user? We also need to ask, what type of media can the user share? From the title, right, we have image sharing platform. But we need to be sure and clarify if it's always going to remain only image, or maybe at some point we want to expand the platform to also do share text, videos, or other types of posts. Another question is, what type of relationship should be between the users? Is it bi-directional relationship or unidirectional relationship? The bi-directional relationship is that one where you are my friend and I'm your friend automatically. So once I follow you, you are following me automatically. That's bi-directional. But the unidirectional relationship is like a follower and a publisher, right? Where I can follow you, but you not follow me. So you see what I'm seeing because you are following me, but I won't see what you are posting because I'm not following you. Okay. Now I want you to start processing it in your mind. What we're talking about here. Finally, what kind of operations can a user perform on our platform? Okay. Now these questions, we are now going to be tackling it one after the other. Okay. Let's assume that when a user registers to our platform, we want them to provide their first name, last name, email, username, password, and a profile image. But if they like, we make it optional for them to provide their age, where they are located, their interests, and maybe some other field that we have not even decided to add yet. We also want to know, when it comes to media that the user can share, let's assume that we indeed allow only images, right? We want only images at this point. But we need to design our system so that adding new types of posts like text, video, and music wouldn't require too many changes. Remember what we said, it must be scalable, right? It must be maintainable. So you have to do it in such a way that create that space, that avenue for change. So even though you are starting with only images, you can upgrade within few changes to adding text, videos, and music to your app. The relationship between the users on our platform is going to be what? Somebody should guess in the comment section. What is the relationship between the users on this platform that we are talking about based on what is on the screen? It is a unidirectional. So every user can follow as many other users as they want, but you don't have to follow them back. It is optional. If you decide to follow them back, all well and good. Okay, but let's look at it and we realize that the formats, whether it's text or video, we don't care at this point. That is what it means by out of scope. Right now, we don't care. We might add it later, but at this point, we really don't care. Okay, now let's assume that, we also ask another question, right? Which we are answering again here, the user actions. Let's assume that the registered user can perform the following operation, right? A user can post a new image. A user can search for other users by name, last name, username, or other attributes. Once they find that user, they can see their public information and look at their shared images. These are the functional requirements that we need the app to do. Then we have the follow and the unfollow functionality, which means that a user can follow as many users as they want, and they can also unfollow them anytime. Finally, when a user logs into their account, they should be able to see a personalized timeline, right? Or news feeds of the latest images posted by those people that they follow. Likewise, those images should be sorted so that when we are doing it, the most recent post is the one that we will see. All right. Let's assume that other activities, like maybe let's say you are leaving the app, like commenting or sharing, let's make it out of the scope now. Or maybe you want to like the app or you want to like the picture. We're not talking about it yet. Can you understand? Somebody, this is the answer to the question of the person in the previous half of the class asking what functional requirements is all about. I believe now you are having more idea about the whole functional requirements. So anybody looking at this thing will understand what the user is supposed to be able to do. So this is like the minimum viable product, the MVP. This app must do this at the end of it. Now, how do we design it in such a way that these functionalities are aligned in the best way? Okay, so it looks like we have a pretty decent number of features, right, that we need to design. Remember that we left some as out of scope, which when you have time, you can always improve upon. Okay, now we will talk about the non-functional requirements. But before we jump into this next level, it is important for us to capture the quality attributes of what we call non-functional requirements of the system. Mind you, even if we design a system that is functionally correct, but becomes completely useless for the workload we intend to use this system for. So that is why we need to consider scalability. If you put too much thing on it and it's not scalable, even though you have a good functioning app, but you did not consider the number of people that will use it. Let's assume that we are designing for a global scale with billions of active users and hundreds of millions of other users that visit the platform every day. And then each user on the average shares one image per day. And I'm sure some people even share more than one image per day. But let's say minimum, okay? And so that each image typically takes like few megabytes, say 2 MB. Say your image is very small. Most times it's even higher than 2 MB. If you're using a very high quality phone or photo or camera, or all these new generation things for taking pictures. So we're talking about the order of that magnitude of terabyte or petabyte of that new data we need to process daily. 1 PB per day is 1 petabyte per day. That is very, very large. Okay, now we'll now talk about the availability and the fault tolerance. Okay, we're defining and definitely aiming at high level availability here. While we may seem like nothing terrible can happen if an image sharing platform goes down, but let's not. Because if we get to that point where we want to monetize this platform through ads, or maybe even by paying people to share photo of important events in real time, so our system cannot afford now at all. If our system becomes unavailable, what happens? Some of the users will risk losing a lot of money. So in that case, we have to aim for nines of availability. We call it nines. Like 9 means 9.9 is 9.99999 is better than 9. Do you understand? Like all those nine, and the higher the nines, the better it is for the up. Okay. So, and that is why I'm saying here that we need to consider the nines. Okay. Now, what else do we need to consider? The payload for every interaction with our system. So when you're talking about designing, you need to consider, how do we design the payload, right? We don't want the app to be loading and rolling and rolling. What happened? People will just keep dropping. Once they realize that it takes forever to load, they'll say it's not working. Otherwise, users will just get bored or frustrated and move on to something else. They won't use your app. So we have to aim at around 500 milliseconds of the end of the latency for the response time. Like within the twinkle of an eye, it's up. And now when loading that personalized feeds, right, that's the view of the other people that's already posted, that their timeline, right, it immediately we want it to show, so that we'll set the response time to a service level agreement of under 1000 milliseconds at 99th percentile. So it is like 1 second or less than a second. That is just 1000 millisecond mean. So 1 milligram is 1 milli is 1000. So 1000 milliseconds is a second. Now, less than a second. So before you blink, what happens? The update has been done. And that is the only way you would enjoy the application. Now, I'm going to be showing you this design. You might want to expand your screen if you want to see it better. All right. Or if you have the lesson already, you can check it. Okay. So now that we have narrowed down the scope of our design and have captured the functional and non-functional requirements, let's move on to the next part of the design, which is the definition of the system's API. So since we have a lot of features that we need to implement, it's better for us to put it in a sequence diagram. Now, I remember in the last half of the class, somebody was asking me about the sequence diagram. Now, this is what a sequence diagram looks like. You will see that user A, what happens? Does it and goes to the registration page. Okay, so we'll talk about it. This way we ensure we don't miss any important detail. You can see that it's very explicit. It's very high level. We started with, okay, what exactly do we need? Does it look like? What is the process itself? In a sequence, and then we turn it into a diagram. This way we ensure we don't miss any important details as the side benefits, and the API definition will be much easier. If you notice on top, you have something like get home page. So we already in our mind, we're thinking when a user logs into that system, the first thing they see is what? The home page, right? And to get there, what does it do? Let it call an API called get home page. So a function called get home page is what it will call, which is an API that is working for that, right? Okay. So for simplicity, let me try to explain this diagram. The actor in our system are two different users, user A and user B. And our system is in the middle. Okay. When a new user comes in, that is the one on the left-hand side, the one in pink, user A. It makes a request to our system to load the registration page. After that, they get the registration page to their browser. And they fill in their information and also upload their profile photo as part of the process. So it calls the function get home page. It shows the page. Once it shows the page, what happens? It starts the registration. Once our system receives the registration data, what function will it call to receive the registration data? Let's call it register new user function, right? So that endpoint we call the register new user function, right? Which is a post request. So when we upload our photo and everything, and once our system receives it, what happens is ensure that the username is not already taken, right? Okay. Then it stores the user information and logs them in our platform. And that is why we have the system. If you see the middle, you see something like store user details, where it stores the user ID and the token. Now, what happens? At that same time, we have another user called user B. He's already registered. He's not a new user. So all it just does is what? It simply logs into our platform by providing their username and password, right? Okay. Let's go back to user A. User A can post as many images as they want. And in each case, we will store that image and send it back. And that is why we have the function post image. It calls the API. So the API calls the function post image, right? And what do we need for that API? We know that we are going to need the user ID and we're going to need that image. And then we get the confirmation, right, that, oh, it has been posted. And what happens to the image? It stores the user image. Okay. Then that user B that is already logged in can look for user A. You can just search. Okay? Search the user by the last name or the first name or the username. So that process of searching is what? There's an API responsible for that one that calls the search user function. And then it searches for user A. Can you see how we are breaking it down bit by bit in a way that anybody looking at the system can understand it? And if a user matches that search, we send back a page with user A's information and all the images that the user A has already uploaded. Notice that this number of images can be very big. So at the point where it is too big, what happens? We will implement this call using API pagination. So at that point where you are doing page with user A images, you will apply pagination so that your app will not crash. It will just be showing it one after the other. For things like Instagram, it is auto scrolling. So as you're scrolling, it is scrolling and capturing just your screen view, and then you scroll again, then it loads the rest of it. Then you scroll again, then you load the rest of it. And that is why you see that sometimes when maybe your data finished, right? The one that you have scrolled, that your data has loaded, maybe like two extra images are the only one that you will see. The rest of them will just be blank, like empty. That is because at that point it only loaded few of them and did not load all of it. Right. Okay. Now that you have searched, right, user B can start following user A. Okay, which could be another API call, right? And that's why we have follow user function. And what do we need in this follow user function? We need the user ID, the person that wants to follow somebody, and the person I want to follow. That's the target and the follower. Okay. Now, when the user B comes back and log into our system, they should be able to see the news feeds of all the images that user A and all the other users that user B is following. And it is sorted by what? The timestamp of their home. So that means at the time every activity is happening, there's a time appended to it. And that time is what you will now need to do what? To arrange that feed. And that's why you see that the latest thing is always, you'll be seeing something on the top of your Instagram like updated now. You will not, when you open it, you will not see what has happened in 2023. That's not the one that's not the first one you will see. It is the latest one that you will see. Exactly. That is exactly what we mean by sorting by the timestamp. Of course, we will also apply pagination as well, or infinite scrolling, depending on what functionality we want to achieve there. Otherwise, if we don't do that, we end up returning too many results that we end up slowing down the page. It is to help your page to be very, very fast. Now, if we take every interaction between the user and our system, as well as that data that we pass in each call, we have our system's API fully defined. Right. Okay. Now we can use this API and move on to the next step of our design, which is the functional diagram of our system. It is worth pointing out that it is an abstract representation of the API, and if you want to implement it in the way we implement the system, we have to translate it like that of the REST API so that we'll understand better what it is. Now, we can see from this page that the get home page function displays the registration page. The register new user gets all the data that it needs and returns your user ID and your token. So these are like your API that you, from the initial design, you already know. Can you see that there is no back and forth? You already know that this is what will happen. And then when you log in also, you also get your token, right? Which can expire, which you can design to expire within the time that you feel. But most are always 3,600 anyways. Now, we go ahead to the post image function. And when you post, you get a confirmation that, okay, this image has been successfully uploaded. And then you have the set user functionality, where you put either the name or the last name or whatever you want to put, and then you do what? You get the images of that person. Another function is the follow user function, right? Where we talked about again, where when you follow the user, you are sending your own ID and the person you want to follow, who is the target, right? And then what happens? You get a response. You have successfully followed this person. You will see that either love icon or whatever icon that they may be using to represent it. Now, we also have get timeline. This is the function that we're talking about earlier, where you call that function, it gets the ID of that person that is logged in, and what? It displays the images of all the people that the user is following, right? Okay. Now, this is the functional requirements diagram. You can see is this software architecture diagram handling the functional requirement. Okay. We already know that functional requirement is abstract, right? It's high level. Okay. We can easily translate it to REST API or any type of specific API easily, right? But we're not going to spend time on this. And we'll just quickly have a quick recap, right? We'll start with the very ambiguous and high level description of our system, which is just image sharing, right? It's a social media platform for image sharing, and it can mean different things. So now, after following 3 steps of our system design processes, we have a very well-defined set of features that we need to deliver, right? With quality attributes that guarantees that that API will have a very lovely and strong, durable architecture. So we'll continue our design process for the large-scale image sharing social media platform, right? After gathering all the functional requirements and we have defined the system API, we are ready to sketch our software architecture diagram. And this is what you're seeing on the screen. Focusing primarily now just on the functional aspect of the system alone. So, as we can see from our sequence diagram, the first step of a user coming to our system is what? Getting to the home page. All right? Now, and registering on our platform. So it's either the user is getting to the home page or registering. Please try to have a look at how the arrows are moving. So let's start with creating the web application service, because this one is the one that will handle the what? the registration. It will handle both scenarios. So when user A is registering, user A is the new user. It was definitely go to the web app service. Even the one that is already registered before, that is coming in as a second user, will also go to the what? To the web app service. So this is where a user can send initial requests. And depending on whether the user is already registered or not, we will send back either a login page or a registration page. Okay. Now, we need another service which we will call the user service. Is the one on the top right. That service, what does it do? It stores all the users in its own database. So as the web service is done registering, it saves the value. And that is why you see that what? The user A arrow points and goes directly to user service at whether to register or to log in. You can see how we are changing our sequence diagram to look like architectural diagram. Now, each record inside that user database will include what? Definitely, we have the unique user ID, the public informations, like the information that you want to show to the general public, which are the username, the first name, the last name, the profile image. And then we also have the private informations, which are the password, the email, and maybe even phone number, so that you can implement your two-factor authentication. Okay. Additionally, it will also include a bunch of optional attributes, such as the location, the age, the interest, and many others that we may want to add in the future. Right? Okay. Now, we could try to store the image inside the database, but this is not a good approach at all. In fact, it's a very terrible approach. In fact, if there's another adjective to qualify terrible, let us use it. Why? This is because databases are not optimized to store binary objects. We all know that images are binary objects, right? And even those that do support them, they set a pretty low size limit on such objects. So what do? We are going to add an object store. That's what we have here. Just above the web app. Just above the web app service, you are going to have the object store. Okay? And so instead, that object store is the one that will now store the profile image, right? We will now use the URL of that image in that object store and go and put it in the profile image. So what we will have in our database is what? Profile image URL. So anytime you need it, what do? You get the image URL and then you go to your object store and you get that image out. Okay. Now, as we can see, the schema of the user record is pretty fluid because of all these optional fields, which we already have and may have more in the future. So because we don't want to, we don't know everything that we will need, we will choose a NoSQL document store for storing the user data. NoSQL does not require you setting up the whole thing. You can always add more to that data. You can always just drop another value. But for SQL database, of course, you have to set your structure and you cannot add any other thing to it again. If you want to do it, maybe you have to do another migration or all those kind of things. And that is why for this thing, we'll be considering the NoSQL document store for storing the user's database. Okay. So now, a user's registration request will first go to the user service, which in turn will store the image in the object store, right? And return the image URL. Then the user service can add that new entry to the user's collection. and return its newly created user with the ID and the authenticated token. Using these two pieces of information that we have now, we can now continue interacting with our platform and call our API. We already know the APIs that we will call. We discussed that in the last slide. Now, let's move on to the next API call, which is the login request. Okay? What does the login request do? All login request does is authenticate the user. If you don't give the username and password, what happens? It tell you you need to put the correct username and password. But then, if it does, what happens? It looks up that user that is existing in the database, and if that user is existing and the password matches the hash password that you already have, what do? The user service will return the user ID and the token, just like when you are doing the user registration. Now let's move on to the next API call, which is posting. And when you post or you share a new image, for that we'll create another service called the post service. You will see that there's an arrow right from that user A to the post service. If we want to extend our platform to other type of posts beyond just images, we can keep using this service. Anything requiring posts, right? And of course, this service will have its own database inside the DB as well. We need to note that for each post, we will store the unique post ID, the user ID, which refers to the user that is sharing the image, then the URL that points to the location of the image, and the timestamp that indicates when the image was uploaded. These are the things we will need for the post service. And now, to support other type of posts in the future, we can also add a post type of column, which for now will always be a type of image. Okay, at this point, what do we want to do next? We want to know that if we want to store this kind of information, what we can do is to store is to use both the SQL and the NoSQL database. But since this schema here is pretty defined, we already know what we want to do. And of course, it fits naturally into a table structure. That's why we are going to use the SQL database for the post service, because we already know what a post entails. We already know everything that we want to post, compared to the ones that we don't know what we want to post, and that's why we're using that NoSQL for the user service. But for the post service, we already know the things that you can post, and then we have added another extra column for the type of the image later, in case if you have a type, you can now say that type can be video, can be text, can be whatever it is. If you call it a type, it can be anything, and then you can always use that type to modify your system in any way you want. Okay, the service will upload so when the user uploads an image now, that request will go to the post service, right? The service will upload the image to the object store and add an entry for that post in its database. Remember, we have object store here. Anything related to image is in what? Object store. And remember, we are taking this thing on the high level. We are not deep diving. Okay. Once the insertion is successful, the user gets a what? Confirmation. Now, let's move on to the next functional requirement, which is searching for our user by username. All right. First name, last name, or any other type of attribute is what we can use to search. Now, we could simply send that request to that user service, but we would like to use a better approach now, right? And that would be to have a dedicated search service with its own NoSQL database. Can you see how we are doing this thing one after the other and having a service for each one of them? That comes with a highly prioritized, optimized test search engine. right? And this way we can support like faster or even more advanced search functionality with the system provided suggestions. So of course the system will tell us what we want to search and keep the user database and search database in sync. So the user service and the search service, they must always be in sync, and that's why you see that there's a link between them. Because when you are searching, you are searching the users, right? So you need to understand that it must be updated all the time. And so to keep the user database and the search database in sync, what do? We will use event-driven architecture and access pattern. And that's why you have those things that look like chain between user service and search service. Okay. Now, using this pattern, what will happen is that any update to an existing user or registration of a new user will be published as an event to the message broker by the user service. And the search service will subscribe to those events. So as everything is happening, it's just like you are getting a news feed. It's just like somebody telling search service that, hey, user A has updated this. I hope you are aware. Search service say, okay, yes, I'm aware. Oh, user A has done this again. Okay, I'm aware. So that by the time user A is now doing a search service will not say, oh, I did not know, I can't find it. Because he has already gotten the information, it will be able to provide that information for them to consume. All right. So now every search request will go to the search service, which will in turn pull data from its own database because it has already subscribed to the changes by event-driven activities from the user service. This way, we can quickly return search results and even show potential matches to the user as they are typing their search. And that's why you see some apps that are not making use of this event-driven functionality. They are very slow when you are searching, and you wonder, why is it taking so long to just search? This is what is happening. Can you see that we've not even talked about indexing or all these things here? This is still high level. Okay, now let's move on to the next requirement, which is the ability for the user to follow or unfollow other users. If we want to be very granular in our microservice architecture, we could create a new follower service, right? With its own database. However, in this point, it's not necessary. Why? Because it can be represented with a simple mapping inside the user service database. So we don't need to do another follower service database. Each entry in this collection contains the follower user ID, which is just the user ID of that follower, and the target user, which is the user being followed. So if a user follows user B and user C, then we will have two entries that looks like this, right? And if user C also follows user A in return, then we will have the following additional entry, and that's it. So now, the follow user request will go to the user database, and we will add the appropriate entry to the followers collection if that entry doesn't already exist. Now, similarly, in this case, if a user changes their mind and wants to unfollow a user, what happens? They can also do it very easily because it follows the same pattern. Now, let's move on to the last requirement, which is the personalized timeline or the news feeds that you get when you open your app and you see the latest post of people you are following. For example, if user A is following user B now and user C, then once user A logs in, we will show the latest post from both user B and user C. So what would be the best way to achieve this? What would be the best way? Let's talk about this one way we can do it. Anytime a user opens the home page, we can send a request to the user service first to look up all the users that user A is following. Then given that list, we can then send a second request to the post service. This post service will then have to perform a complex SQL query that filters all the target user that user A is following. and then sort them by timestamp in a descending order. Of course, we know that this request will return very many results, right? And we will have to imply on pagination here or auto infinite scrolling. And now, after this complex query completes, we send those post requests back to the client. And that is why we have these arrows. Finally, the client, remember the client side is user A and user B. Finally, the client side will have to issue another batch of requests to the image object store to actually load those images into the browser. Remember, the image is different, so we have to do it separately, and that's why we call that object store. Then you get the links for all those things, and then you now load those images. As you can already see that this approach is very inefficient. It doesn't even make any sense and simply won't work if we have hundreds of millions of each request coming to our system daily. But normally, this is how anybody will actually reason in the first place, especially given the strict performance requirement that we received and we want to use, looking at the scope of this thing. So while we can certainly improve the performance of the last operation, we can't completely eliminate it, right? We can do something about the first two parts. Remember what I said in the beginning of the class. First of all, write it down, then start improving on it. Right? Now that you have known all the services that you need and everything, in particular, we can definitely eliminate negative performance impact of this complex SQL query. We don't even want to have that at all. So we will use two patterns to improve the performance of this operation. We'll be using the seeker pattern and the materialized view pattern. First, what do? We will introduce another service, which we call the timeline service, and that's why we have it in the middle. In other words, every user will have an entry that maps from the user ID to a sorted list of image coming from all the users that the given user is following. Let's say, for example, if user A is following user B and user C, then we will have an entry for user A that contains all the posts from user B and C in a sorted order. So we have already planned it for user A. Similarly, if we are using user C, if user C also follows user A, what will happen is that user C will have only posts that user A shared recently. So we have like isolated that value for timelines. So we don't have to start running queries all the time. And of course, since user B is not following anyone, his timeline will remain empty. Every post record comes with the post image URL, the ID of the user who posted it, and its timestamp. Now, all we need is just a simple mapping of key and value, right? And that is why we have it under that thing. We have something like key/value store. But we're not done yet. We will also introduce a message broker, which the timeline service will subscribe to. Okay? And now, anytime a user posts a new image, what happens is that the post service will produce an event that includes the user ID, the post URL, and the timestamp for that image. Now, that timeline service, in turn, will consume that event asynchronously, which means the user will not be impacted, and it will send a request to the user service to get the followers of that current user, like doing a background work. Once the timeline service has the ID of all the followers of the current user, it will then update the entry of those followers with the new posts and place it in front of the list. Why? The reason is it goes to the front of the list of each user is that the post is now the most recent, and since the number of recent posts in each user timeline is constant, it will always push off the latest recent post out of the list, the least recent post. So if you have 10 and then it just jumps off and then push the remaining one. Let's say you want to be showing 10 posts at a time. This way we always keep the timeline posts chronologically ordered. So whenever we just call that timeline request like this, what happens? It is ready made. It is giving you back immediately. And that is why you see that your Instagram loads fast and well, because it has already done all these things at the background. Okay, it can directly go and fetch. So once the client code receive the list of URL, then what happens? You know, it is URL that it is getting from that place, that service. It will now immediately go and fetch those images from object store. While we still have many things we can optimize, it is a better improvement, right, on the timeline experience for our users. Of course, there's still a clear downtime that we have in this approach, which is that new images posted by user will show up on their followers timeline not immediately, since we have only eventual consistencies. But that's completely acceptable at this point. We will work on it. Now, we have successfully completed our software architecture diagram, which fulfills all the functional requirements and maps every API call to a path within our system, like we have done in the previous slide. And in particular, we have placed the profile image and the post image in an object store, which is much better type of storage solution for this type of data. We also use the pattern to separate the user registration and the user update operation, which now go only to the user service from the search operations. That so now when we're searching, it just goes to user direct and search operation does an handshake with user service, and then we have everything ready. Once you are searching, you are getting your stuff back. And finally, we use the seekers and materialize view pattern together to optimize getting the timeline for our users. In this case, we avoid performing multiple requests to different services. And in addition, we also avoid complex SQL query against our post database. Instead, what we are doing is using this pattern that we have cached view of each user's timeline in the timeline service database. And we have already ordered it in a way that is already made for the front-end code. So now we're going to have a look at this iteration and make the necessary update to make it more high performance with high availability and scalability. And that is why we have this. So what do we have here? Can you see that it is quite different? What is different here is that now we are going to focus on addressing the non-functional requirements. Remember, non-functional requirements includes performance, scalability, availability, right? And that is what we are now introducing. Can you see that we are picking it bit by bit by bit? We did not start with this one. We started with diagram, sequence diagram. We went on to the architecture of the functional one that captures the main one, and then we are now adding the non-functional requirement to what we already have. Right. Now we're going to focus on the updates of this diagram. What have we updated? As a reminder, these are the quality attribute requirements we gathered initially that we said we're going to add. Okay. In this first part, we see that we have billions of users with hundreds of millions visiting our platform daily, right? So let's go back and see what we can change here. To scale our web application service, we can simply run many identical instances and place them behind the load balancer. All right. This way, no matter how many users we have visiting our platform, what do? We simply increase the number. Okay. So this the instances will just, when you see that, oh, okay, this store is not enough, what happens? It just automatically increases it. Similarly, to support many users logging in as well, we place the user service behind the load balancer and run multiple instances for that service. So if this one is failing, it just switches to the next one. We store our user data in a NoSQL document store like we did before, where each user is represented by separate record. Our time is fast spent, so I'm going to try to just summarize the rest of it so that we don't take much of our time. So we will use sharding and distribute this data across multiple physical instances. And the simplest way to shard this data would be by using a hash strategy applied on the user ID. What does this do? It will distribute our users among as many shards as we want. and we keep getting more users, we can add more shard and redistribute the users among all of them. Of course, we need to make sure that those IDs are randomly generated using a uniform distribution. Otherwise, what happens? Some shard may get overloaded with more data from one than others. So we have to make sure that it is evenly distributed. Similarly, we have to do that as well for the followers. So we do it for everything. And remember, the followers timeline has to do with the post and the timeline services. Okay. Now, at that point, we handle the key value pair. So everything is just about adding load balancer to everything. Okay. Now, what about the high availability and fault tolerance of the service side? We actually do not need to do anything. What we just have to do is having multiple replica of each service behind the load balancer. And that's why we have something like this on the left hand side. Can you see that we have like a tree, a something beside on the left hand side of each of those services? There is something there. All right. So operation can easily go to other replica once that one is done. This way, a power or network outage in one part of one data center will not impact our user, and it will not cause a complete failure on the data center. Okay, now we can use content delivery for services by pushing our site static content like HTML, CSS, JavaScript to the edge servers as well as the post images. All right. So if we could have, if we can even delegated a compression of image to the CDN service, if we want to, we can compress it. But regardless, the fact that CDN servers need to send smaller image into reducing the latency improves our user experience enough. Now let's talk about the performance of fetching our user timeline, right? From the timeline services to the browser. What happens? Thanks to the decision that we have made in this architecture, by creating the service and storing a cached material view of each user's timeline, we have already made a huge step in providing a high performance for the system. However, we can find a few additional critical optimization that we want to do here. The first one will be the case of a celebrity or an influencer that has hundreds of millions of followers who post very frequently. Although there are many few users compared to the total number of users on the platform, their impact on our performance can be very significant. And the reason for that is that every time such an influencer makes a post, our timeline service will have to insert that post into potentially hundreds and millions of collection. This puts a high level load on that service and its database, which can make billions of write operation, and that will be very expensive. So now, if we have few thousands influencers in the platform, this collection will relatively be small because we have integrated the search service timeline. Okay, now that we have had all those things, right? Before we move on to the next design problem, let's summarize this, right? What do? We introduce a load balancer, and then we run each service as a group of identical application instance. On the database side, what did we do? We use sharding technique with the hash-based sharding strategy, so we can store more data that could effectively fit on one single database. And additionally, we process the use uploaded images, right, to save on storage space and cost associated with it. Finally, what was the last thing we did? We added an API gateway to decouple our front-end code from the rest of the system to provide high availability. We added database replication as well and ran our system in multiple isolated zone and geographical locations. And lastly, we improved the performance of our system by first introducing a content delivery network and publishing our images as well as other static content to its edge servers. As the final step, we optimize our timeline service and introduce another collection which we can store the posts of popular users such as celebrities or influencers. And then whenever the user wants to get their most updated timeline, we make the data from the user's timeline and the influencer's post collection, and that is it. So that is the summary of this whole thing. Our time is fast spent now, and there was a question I was supposed to ask you, but I think we are going to just skip that and have to figure out. But I will just wrap it up with you and tell you that in in our image sharing platform, we have user A to user B, right? Now, before we added the timeline, this is what it has. What do you think is happening here? What is simply happening here is that the answer is C. And what it does is you send a request to the user service, you get back Daniel, Mary, and Jane, and then you send a request to the timeline service, which will perform a quick lookup for all the recent posts that Daniel, Mary, and Jane have recently posted. Then the first step is you get back all the list of the URLs for the posts from Daniel, Mary, and Jane. And then you send a request for each post URL to the object store, and you get back the image for each post from the object store. That is the sequence. And then for the second question that I was supposed to ask you, sorry, I have to wrap up because time has gone. So you can always just sit down with it and learn it on your own. And for this one, the after we have added the timeline service, what is the difference? The difference is that we skip what? We skip that user service, and then we send a request to timeline service directly, right? Which would perform a quick uplook for recent posts, get back the list of URL, send a request for each post, and get back the image from each post, thereby saving us time, and we're able to achieve things better. Okay, and that takes us to the next end of the class. Sorry, this is extended. This was because we started a bit late, right? And the next class will be understanding software requirements and user stories. Please feel free to sit down and think about it. You can use lucid charts to do your system design very well, and just sit down and just try to come up with something, starting with um, sequence first, then moving to functional, then adding your non-functional. And with that, we come to the end of the class. I'm sorry, I won't be able to take questions anymore because uh, I'm seeing some questions. So I'll give you, we have a minute left. And all I want to know is, let me answer some question here. All I want to know is a realistic timeline to do on all this. If one person can get an in-depth knowledge of all the damn your timeline depends on you. It is how much energy you put into it that will determine how much time it will take you. And the more you know it, the easier it is for you to do it over and over. So the first time can take you weeks or days, right? The second time can take you just one day, and the third time you are working on it can take you hours, like a professional. And that is what makes you a professional. That is what how you become an experienced software engineer. Now, I feel this topic, I have another question. I feel this topic should have been treated differently, if possible, for easier digest. Oh, okay. Yeah, thank you, Oludari, for that. Please feel free. Diamond said, please, ma, while building an app's backend, does it mean every activity to be carried out in the app that we build, we need to write a different API for each one of them? Not in all instances, and that is why I said that you have to look at what you are doing and look at what works for it. You know, you are dealing with thousands of people, right? And then you have REST APIs now. There's an API that does read, right? Right. So all those things matters a lot. So delete and all those things. What happens when a user unfollows another user? It calls that follow endpoint again. It follows the same format, but in this time around, instead of activating, it is deactivating. Thank you so much, everyone. At this point, I will need to end the class, and I hope you enjoy the rest of the day. Do have a wonderful time. Thank you very much, and bye bye.